Hey everybody. I wanted to take a minute to go through the how the how you find the trig values for sine and cosine at the uh, 0, 90, 180, 270, back to 360 at those quadrantal angles. That's the way it's termed on the Trigging It Up with Sully handout. And I go through it on the handout, but I think a dynamic, moving representation of it will probably be a little more helpful. So that's what we're going to do right now. Okay, so first I'm going to take a look at sine, and sine is opposite over hypotenuse. So I've got the ratio of those two sides. At this point, it's zero point 0.8, which means that AC here is 4/5 or zero point 0.8 of AB. If I move this closer to 0, you see that this opposite side is getting smaller, and therefore the sine value also getting smaller. The hypotenuse, because it's the radius of the circle, isn't going to change. And so as I drop down here, that opposites get smaller and smaller and smaller. So when I get down to 0, the opposite side is gone, and that's why the sine of 0 degrees is 0. Also the same thing for the sine of 360 degrees. As I move it back up, it gets larger and larger and larger, and as I'm getting closer here, I can see that these two side lengths are almost identical. It's right now AC is 98% of AB. They are almost the same size. As I get closer and closer and closer, eventually the opposite and hypotenuse become exactly the same size, and therefore the opposite over hypotenuse will be 1 when I get to this value. It actually turns closer here because it'd be more decimal places out there, but it rounds it off, so that's why it turns there earlier. As I come over here, my opposite side is still positive because it's above the x-axis. It's in the y direction. It's positive y values there. But as I get closer to 180, I see that opposite side shrinking, and therefore sine is going to shrink down until I hit this point, and then the opposite over hypotenuse is 0 once I get it right on the axis, which I can't get it exactly there, but you can see what it's doing. When I rotate down on into the third quadrant, now this opposite side will be negative. I can't show that on this software program, so it's going to still look positive over here, but the opposite is negative in the negative y direction. Remember, the hypotenuse is always positive no matter where it's at. Um, so this will, so sine values would all be negative here in the third quadrant because the opposite's negative. As I get closer, right? Opposite and hypotenuse are nearly the same. At this point, they're exactly the same, but the opposite is sine sensitive, so it's still a negative length. And so this sine value at 270 degrees, or at 3 pi over 2 if you're in radians, is going to be -1, not +1. Sine would continue to be negative in the fourth quadrant because this opposite's going to be negative over a positive hypotenuse. So sine values in the fourth quadrant are also negative, and then the opposite's getting smaller as I get closer to 360 degrees. And when I hit 360, the opposite's gone, and I'm back to a sine of 0 again. The same relationship plays out with cosine, except I'm looking at this adjacent side and its ratio to the opposite. If I pull it down, my adjacent's getting longer and longer until adjacent and hypotenuse are equal. And so the cosine of 0 is 1. As I range it up, I can see my adjacent sides getting really small as I get closer. And so once it hits the axis, the adjacent side is 0, and therefore the cosine of 90 degrees, or the cosine of pi over 2, is 0. Since cosine depends on the adjacent, it's going to be negative in the second quadrant. This is in the x direction, so the adjacent side here will be negative. And so as I approach 180 degrees, or pi radians, uh, adjacent and hypotenuse will be the same length, but the adjacent is negative. So the cosine of 180 degrees, or the cosine of pi radians, will be -1, not positive, the one the way it shows on the screen. Cosine's still negative over here because this adjacent's still in the negative x direction. Once I hit 270, the adjacent side is gone, so cosine's back to 0. And then once I get back over here, now the adjacent side is in the positive x direction. So cosine will be positive in the fourth quadrant. And as I get closer to 360, adjacent and hypotenuse approach the same thing. When I get there, they're identical. And so the cosine of 360 will be back to 1. This will help you get the little table filled out, and you will use that table then to deal with the other 4 trig functions. I'm going to give you just a real brief rundown of tangent here. Tangent is sine over cosine. So I can see that when sine is 0, tangent will be 0. When I bring it up here, this is where the interesting stuff happens. Tangent right here is that length over that length. Well, there, those 2 lengths. Well, this is getting closer to the radius, but this is approaching 0. And if you divide something by a really small number, look what happens. The tangent is there is almost 6 already. And as I bring it closer, now we're up to 12, 13, 15, 17, 22. See how close I, ooh, 131. Right. And ooh, 778. It's probably the biggest I can get it. But actually tangent at 90 degrees, because I'm taking this value and dividing by an almost 0, tangent is actually going to infinity right there. So we would say that the tangent of 90 degrees or a tangent of pi over 2 is undefined, but that's because it's not defined because it's going to infinity. And so you're just going to use the sine and cosine identities from the first page of the Trigging It Up with Sully handout to fill in the rest of that table. And then the next video after this, we'll start going into the graphing of the all 6 trig functions and how you can remember how to do those graphs. So hopefully this is helpful for you, and I will talk to you next time.